Good afternoon, DDD. Last talk before the closing lock note. Looking forward to Rendell's talk. I'm going to be chatting to you about open telemetry today. Interestingly enough, the observability space has been going through a little bit of a trying to coin new terms and differentiating a lot of the changes that have been happening. There's a lot of talk about Observability 2.0 and the issues that a lot of people are facing around just understanding what's happening in their apps as things get more complicated. Who's been in the situation before where you have... Oh, 2 seconds. Helps if that's turned on. Where something's going on and you think there's a problem, but you're not quite sure, and you're trying to go through your logs and figure out what's going on, and it's like, yeah, I think everything's okay. Who just really doesn't have a huge amount of idea what's happening in their apps? Thanks. The truth starts coming out. Reality is, we've just been trying to continually get better over time. We never get things right as an industry as when we first start, and then we have a bunch of ideas that we try and standardize around. There was one quite a while ago. Does anyone remember the 12-factor app in terms of good app design? Cool. This one's been around for a little while, and a lot of kind of pushing forward in the logging ecosystem and libraries and various different approaches kind of started centering around this 12-factor application, which was just, these are 12 patterns that if you follow, you'll be able to run your application in production a lot easier. They say a few things about logging, and so you don't have to read this, but essentially logs are a stream of time-ordered events that are just outputted to the standard out of your application. So as a 12-factor application, you should just have a single log message per line that goes out to standard out, and then something else picks that up, puts it to the file system, or sends it to a collector or something along those lines. Because we don't use VMs anymore, right? This is the typical kind of architecture. You've got your app logging out to standard out, then you have some sort of agent picking up those logs and sending it to a log aggregation tool of some sort, like Log Analytics or Sumo Logic or something along those lines. This goes us a reasonable way, but then it's like, what about my dashboards? How am I going to kind of pull specific information around like how long requests took, or that was kind of covered, but then we start getting into more domain-specific problems. So generally, apps got split into 2 main categories. You had your logs and then your metrics. We'll start with metrics because they allow us to answer the dashboard question. So there's a couple of types of metrics that our applications have. You've kind of got your counters, which is just an incrementing number like your odometer on your car. Just keeps going up. This is how many requests I've had, how many purchases people have made, something that just continually goes up. You've got a gauge, which is generally like a fuel gauge that can go up and down, and it's just a measure of where something is at. And then you have a histogram, which is generally like a aggregation over time. So this would be error rates or request duration or something along those lines of, you can see your average request duration for your application. So they're kind of the 3 types of metrics that we would use in our application to kind of gather specific information about how our app is behaving. So this is pretty good. We then come back to logs. The original kind of logging format was this, which is broken up into like your host, the user identifier, date, request, status, and then the bytes. So this was kind of like a standard for request logging. And the issue with logging into a text format is it is just a string at the end of the day, and it means nothing until you parse those things back out. So this was a common log format for HTTP servers, so you could quickly output your logs from all your requests and see how long they took, what the request type was, what the status codes are, those sort of key bits of information. And then down the track, we kind of had a more generic thing where you've just got your log level, some sort of timestamp and a message. Now, this is very lossy. We have trouble parsing this back out. If there's domain-specific information, like this is the user ID, this is a correlation ID, this is the request ID, there's normally information attached to our logs that we put into these messages. So we kind of evolved that into structured logging, where we would create an object, and generally we'd format it out as a JSON object on a single line in our logs or to our standard out. And that allowed us to attach any sort of metadata. This was really good, and a heap of tools kind of started adopting it, and we could just send JSON to standard out. It would be picked up by the agent, ingested by one of our log analytic tools, and that would essentially give us the ability to query over any of these attributes. Now, what happens when something breaks in this scenario? Has anyone tried to figure out and reverse engineer how this service talked to this, what came first? Oh, why is that log after that? Didn't that happen before? Those services have some sort of time drift. It becomes really challenging to piece these streams of logs back together to actually figure out what happened. The other problem with logging is you don't know what to log until something breaks. So I've had many a times, which I'm sure you have as well, where you know something's broken in production, you've got a pretty good idea of what it was that broke, but that was a debug level log. We don't have that information, I can't prove it. The boat's kind of left already, and you've lost the ability to have that information. And this is one of the big issues with logging, is you have to answer all of the questions you might have or predict the types of failure you will have in production before it happens. And we're not very good at that. The other kind of issue and trade-off that you start playing with is if you're doing something, this is the well-architected framework pillars, which a lot of the cloud companies publish. They've got these different pillars that if you follow best practices in each of these, you'll have a really, really good quality app. One of the most interesting ones for logging is this cost optimization one, because in terms of spend, does anyone have a quite a large application that gets a lot of traffic? If you do, what's your percentage kind of roughly around how much you spend for log ingestion versus everything else? For any sufficiently large system, sometimes your log ingestion costs completely eclipse everything else, which is, in terms of return on investment, it becomes really challenging. So the first thing you do when you try and save costs is offload a bunch of logs into debug level so they're not on in production, and then you go back to this problem again, where now I've just got rid of a bunch of logging that I needed to debug this issue in production. So there's this annoying trade-off with this observability problem around more observability tends to mean more cost. And that's super, super frustrating. And you end up just walking through trying to figure out these problems without actually having the logs to debug the issues that you're actually trying to debug. It's really, really frustrating. And as I said, it's kind of reverse. You have to figure out what are the questions that I need to answer well before I've kind of shipped it to production. And these are some of the questions you might have to ask. That's terribly small. How long did that operation take? Well, in logging land, you've kind of used the timestamps, and then you try and do some aggregations to figure out what's the duration between this log and this log. Could be what led to this issue. You've got distributed services where the user does something, puts a message on a queue, that gets processed by this back-end system. you've got all of these moving parts with individual logs. How do you know what is kind of upstream? You have to put all of that stuff together yourself with logs. And sometimes the question is just, is something wrong with my system? And that's often quite hard to do, especially if you've, going back to the saving costs, if you're like, oh, I'll turn on log sampling, and then suddenly a whole bunch of your errors are sampled out and you can't actually see that as well. So we said we've got these kind of two primitives that have made up observability for quite some time. The one that's been gathering a lot of momentum over the past few years is tracing. And traces are a bit more interesting. They're similar to structured logs, but they have a duration automatically attached. So if we were to kind of break down what a trace is it is something that captures a bunch of sub-logs that have time. So an example here is my trace. It starts with a GET request. That's kind of your typical HTTP response. This is my home page loading. Within that home page, I've got an operation where I'm going to load the user from the database. That is called a span. The properties of these are traces at a root level, do not have a parent, and then a span is really just a trace that has a parent associated with it. So that load user span, make a call to your database. That has a duration, and it has a result. Each of these spans can have a bunch of metadata attached to it, just like structured logs. And then that load user will come back, and now that I've got my user, I need to load the data for that page, comes in, loads the data, and then finally I render the page. So your trace has a couple of key components to it. And what it looks like is similar to the structured log, except you've got some key bits of information. You've got your trace ID, you've got your span ID, and a whole heap of attributes. Then your child spans, they are exactly the same, except they also have a parent ID. Now, the reason for this is they remove the problem of out of order and timing, because you have explicit parent references. Even if these spans are coming from multiple services with time drift on them, they can be reassembled into a waterfall and a tree later. So it just adds a little bit of extra. And this is comparative to the old one. One of the really interesting properties of it is you'll notice there isn't really a level. Now that we've got a parent-child relationship, we can't just have one level in the middle that is debug, because that would then destroy the tree hierarchy, so you can no longer filter it via various levels. So the mental model around, well, my mental model around this is traces are simply structured logs that add a bit more useful information, mainly around time. So they have explicit parent-child relationships and other types of relationships as well. We'll get into that a little bit later. They have a duration. Now this is a really key thing. So often you've got various tools to be able to see how long things took, rather than having a begin and an end and trying to manually do that in your observability tool. And they finally are a container for events. Now, events are similar to our traditional logs, where they are just a point in time of this thing happened. And you can have a bunch of those things attached to a span. That's really, really handy, because they're kind of all of the extra metadata that you can aggregate and kind of replace your existing logs. So with traces, there's often a question that I get asked is around like, well, when do I use logs and when do I use traces? As you start moving to this new world, you really don't need to worry about logs at all. You can just replace everything with traces and your life will be hopefully a little bit better. The other really nice thing about spans is they can cross process boundaries. So we're often dealing with eventual systems or event-driven systems with multiple services. Open telemetry and this tracing concept introduces some really key kind of concepts. You have the idea of a server, so familiar with like a HTTP server or something along those lines. You can declare that this is a server trace, so it's within some sort of process. You can then have internal traces and spans, so they would be the equivalent of like a function call or something along those lines. You then can have producer and consumer. So if you're sending a message, putting a message on a message bus, and then it gets consumed by a downstream process, you can attach metadata onto that message that says, this is my current span and a bunch of information, and it is of type producer. Then downstream, when that message is picked up, you can start another trace, attaching that information, saying, I am a new trace, but I am a consumer, and now you get a relationship between these multiple traces across processes. Now we're going to get this distributed tracing. And that's really what open telemetry is. If we take a step back, they have a bunch of specifications that include concepts like this. And they've spent a heap of time working on what are these core building blocks around traces, metrics, and logs that are generic that we can embed and take across every ecosystem. So it's real. When you first have a look, there's just a whole bunch of specifications, and it's pretty intimidating. As consumers, we'll get into that a little bit later, you don't really have to worry too much about all of those specifications. They are just a way for the group to work out all of these building blocks that we have. It's similar to all of the web specs that we have around how HTTP works and all of the building blocks. The specs are one thing, and then there's a bunch of libraries that get implemented. OpenTelemetry is more than just the specs, though. It has a whole bunch of libraries and SDKs that go across all of these different ecosystems. So if you're in JavaScript or Ruby or .NET, there will be OpenTelemetry SDKs, which are implementations of those specifications as SDKs. But there's a large problem around all of these integrations and SDKs, and this is one of the reasons why a lot of really big companies like Google and Microsoft are getting behind and investing in OpenTelemetry. And that's because for years, when you've started trying to start your app with, okay, we're using New Relic or we're using Sumo Logic, a lot of them have given you their own SDKs. And those SDKs kind of go, you're using this web framework. I'll hook into that and give you specific tracing and logging for your web framework. At least in the JavaScript ecosystem, there are thousands of different frameworks, and no one vendor can keep up with all of that. And frankly, it's just a waste of everyone's time. If all of these different vendors are trying to save the same problem around, well, I'm using Next.js, I need to have full observability of what's happening in every one of my Next.js requests so I can optimize my app. It doesn't make sense for Sentry and New Relic and the App Insights team, all of them, to build that same integration. So we get building blocks around SDKs. All of those are extensible, and you can install instrumentations into your app. So the OpenTelemetry registry has a heap of different integrations there. It's always growing. They're all open source. And so if I'm using in Node Postgres as my driver, I can install the Postgres instrumentation. This means my application is no longer tied to my vendor, which is a really cool thing. The other side of it is this knowledge becomes really transferable. So as you start learning all of the concepts and SDKs, it doesn't matter which vendor you're using. Like, you can move that knowledge and kind of those observability concepts between all of your applications, which is really, really nifty. So what does it actually look like? I'm going to use the D2D website to show that. Okay. So before I do that, I didn't introduce myself earlier. My name's Jake. I am one of the organizers of D2D and the director of technology. So over the last couple of years, I've been rebuilding the D2D website and have been involved since really D2D started kind of 11 years ago. A lot of my interest around these technologies are simply frustrations with existing tools being vendor lock-in, being unable to kind of have the freedom to move around, but also some of the issues around cost where I've had challenges with log ingestion blowout, and then you're in a contract and the vendor will waive a bunch of your log ingestion fees if you sign up for another 2 years and that sort of stuff. So I've constantly been looking for ways to get out of that loop and also just be able to run websites like D2D really, really cheaply without having these massive, like costly services. So what we're going to do is I'll start the D2D website locally, and we'll see what kind of the open telemetry instrumentation looks like. So I've just loaded up the website here, and if I go to Jaeger and refresh, Jaeger is a Docker container locally. Now this is one of the really cool things about once you don't lock yourself to a vendor, I can spin up Jaeger. It is an open telemetry collector, so you can send your open telemetry logs. Part of the spec includes not just what a trace is, what a metric is, but also the API specification. So if you want to be a collector of open telemetry instrumentation, you can implement those specs, and now anyone that uses those open telemetry SDKs in any language can now send you telemetry data, and you don't have to worry about building all of these SDKs and figuring it all out and designing the APIs and the transport protocols and implementing all of those yourself. All of that, both client and being a consumer, are all part of the open telemetry ecosystem. So those kind of transport and consumption level things are just commodity, and no one has to keep solving them. So I can get started. I've got my D2D website here. The tracing is really, really basic in here, but there's no database, so we don't have a whole bunch of complexity. But you can see here it has all of my HTTP request, go through all of the various attributes on this. So what we can do is jump into the code here. I'll see what it looks like. There's a couple of different building blocks, and the first one is, we'll go down, we'll actually do it in reverse. You've got your SDK, that is your entry point where you configure OpenTelemetry, and then you can attach a whole bunch of extra pieces to it. So the first one that we start configuring is the instrumentations, and the instrumentations know your library. So you can do the HTTP integration that ties into the raw HTTP server instrumentation inside Node. If you're using fetch in Node, you've got the Undici instrumentation. You can hook into Express and Remix, and then any kind of SDKs you want. You just register those instrumentations, that there's a massive community building them, or you can build your own, and that adds all of these things in. You then have like metric readers, and metric readers are something like they can read the memory usage of your application. Any of those kind of background stats that you would like to just read periodically, you can set up a metric reader so it just does that over time. You can process the logs as well. So they have a whole middleware options, so you can transform the logs before you send it out. So if you need to do, say, PII reduction or any of those sort of things, those are all standard, baked into OpenTelemetry. You don't have to do that per vendor. And then finally, you have an exporter. And the exporter there's a few different ones we can use. So Azure Monitor, if you're using the Azure ecosystem, they do not have an OpenTelemetry compatible endpoint, so you can't just send them OpenTelemetry data. Instead, they have their own exporter that takes the internal data structures of OpenTelemetry, converts it to Azure Monitor, and sends it to their services. So any kind of older services that don't support OpenTelemetry later will likely have their own exporters. But if you're using one of the standards like Jaeger, Honeycomb, or any of the tools that have native support for OpenTelemetry, you can just use one of their out-of-the-box trace exporters. So they have kind of HTTP or a few other transport protocols available. A lot of this, I've manually configured it, but there's also auto instrumentation. So you can just say, I'm in Node, give me the standard setup, and it will contain a bunch of default instrumentations from the most popular community plugins. If we go into our homepage, so we've got our routes, and then we'll go into the index here. We can go trace dot get tracer. This is your first kind of entry point, and then we can say start active span. So there's some really cool things you'll see in the way OpenTelemetry works. So I can just create a custom span here. It will give me the span in a callback. There are helpers to make this async and not having to explicitly call end. And then you can add attributes. You can also anywhere in your application, you can also just get the active span, and then I talked about events earlier, which was similar to your logs. So you could kind of add a event to say something's happened with a whole bunch of interesting metadata. So I'm just going to put and I'll leave that outside. So I've just created an active span here. You'll notice I didn't specify what the parent is either. So I'm just going to refresh this. And you can see here I've got my get. That's got my log on it with my event that I raised, and it's also created that parent span. So you don't have to worry about the parent-child relationship, even if you're using async and await. It's using the new Node async context things, and then in .NET as well, it's similar, sort of uses the async stack trace propagation behind the scenes to make sure you don't have to explicitly pass the parent around and you just automatically get that parent-child relationship. So nice and easy, and there's nothing vendor specific. I really do encourage you, as you are building out your applications, just start getting involved with OpenTelemetry, instrumenting your application, because it's all well and good having kind of your requests instrumented, but the more interesting side of things is where you start instrumenting all of your business logic and can use this in a more interesting way. So that was a little bit with OpenTelemetry and kind of what it looks like. So we kind of have gone through a little bit of what are the problems with our traditional logging stack? Why is this big industry collaboration trying to get OpenTelemetry up and running and going to all of this effort around standardization and whatnot. Alluded to a few of these things, but I'm just going to kind of go through where I see the value of like really investing in this stack. So we've got all of these various vendors. They've been around for ages. They do different things. A lot of them have been like separating logs and metrics and now traces. We are moving towards kind of a bit more of a unified data model. But if everyone starts picking up and just using all of the native OpenTelemetry SDKs, you don't really have vendor lock-in. And it's another decision you can defer until later. And it allows you to not worry so much about where each of these bits of data are stored. It's pretty typical that people are using like Prometheus for their metrics, Sumo Logic or something else for their logs, and then all of their front-end traces and waterfall information goes into Sentry. Replace the tool, doesn't really matter, but often those were treated as very, very different services. One of the idea around this push towards OpenTelemetry is moving and kind of Observability 2.0 is trying to move all of these distinct 3 data models into a unified data model. That's really cool because now you don't have to worry about my metrics are over here, my logs are here, my traces and distributed tracing is kind of in this system. You can just worry about I need to know this information about how my system is running in production. But what this gives is allows all these tools and vendors to start trying to differentiate. If they all talk the same wire protocol, all of their integrations into your application is exactly the same, they can start trying to differentiate on the things that matter, and that is surfacing information and giving you true observability into your application, working on new ways of surfacing the data, like AI is an arms race at the moment. Like, can they use AI to do the hard work around searching these traces to pull out very interesting information and tell you exactly where the problem is? It allows that kind of shared investment and a platform for everyone. And this means that even if you're using like a new database ORM, someone can easily just go build the instrumentation for that, open source it. Now, doesn't matter what tooling you're using or what vendor, you are able to just plug in and leverage that community in that open source ecosystem. If you're in another ecosystem, I've talked a lot about kind of the JavaScript ecosystem. In .NET, a lot of the OpenTelemetry is built on the standard diagnostics tracing that's built into .NET, so you don't even know that you are using you don't have to use the OpenTelemetry APIs out of the box. What they do is just provide all of the common exporters, so you can export your .NET app like traces to Jaeger or Honeycomb or whatever OpenTelemetry provider. You might have also seen Microsoft investing heavily in their Aspire platform, and that's a very interesting play because it's got a few components. The first one is allowing you to define how your services start up, the relationship between them, and pre-configure OpenTelemetry with all of these services. And then they've also got the Aspire dashboard, which is quite similar to Jaeger, but it is just a receiver in-memory OpenTelemetry dashboard. And so another really interesting approach is if you're sampling, for instance, you could send sampled information to your large existing one, and then you could send a lot more granular information or not sampled information into something like Aspire, which is in memory, and as soon as it reaches its limit, it starts dropping old traces out. So really, really interesting, gives you the ability to multicast and all of that with only just changing a simple connection string. So it allows everyone to differentiate in their product without having to worry about all of the stuff that isn't really differentiating at all. So next steps, I really encourage everyone just to simply adopt open telemetry. I think it will be better for all of us if the vendors and picking things like your observability stack, it ends up everywhere in your code. And if you're locked to a vendor at that level, it just means that you have very little ability to move and experiment. But also, it's really good having these powerful platforms when you're running in production, but just being able to run an open telemetry service like Jaeger locally, so you don't have to send all of your traces when you're doing local development, is just super, super handy because you're not actually tied to any one product. You focus on making sure your app is instrumented. You use the same tools to debug locally that you're using in production in terms of I use my traces to understand what my application's doing, and I have got myself in the habit of always using tracing to diagnose issues. I've also integrated tracing with my unit tests and end-to-end tests, so I get full traces of exactly what's happening, what's taking the time, and use that as my primary way of debugging before attaching the debugger. I've got a couple of minutes for questions. I'll take a few and then we'll break.
You mentioned tracing end-to-end tests. At what point does your trace become so big? I assume you've got the whole user session from start to end in a root trace. Does the tooling ever fall down? I've used apps and sites and that just couldn't handle those full end-to-end tests. And yes, how did things go, the end-to-end tests?
Yeah, so I've never had that. What I have had is something like a background process that is spinning really quick. So my root span ends up with 20,000 spans in it because it's like a message processor loop or something along those lines. And so I focus on pulling those sort of things out. But I've never really had it falling over. In terms of the larger problem of I'm sending heaps and heaps of data, what we're trying to do is have spans that have a heap of attributes using wide events that have a heap of data, and some of the newer ones have pricing models that make that you get charged per event rather than how much data is being ingested. When you start focusing on those things, you can use services that allow you to sample differently. One of the biggest issues around scaling and sampling is if an error happens, you may have already made the decision to throw away that log because it's been sampled. There are tools out there that will essentially buffer that entire root span and make the decision whether it's sampled at the end of it. So you can make the decision to keep anything that has warnings or errors in it or a status code of above 299, and then you can apply a really, really heavy sampling. But I've never seen it fall over because of too much data, and I think that's where the idea of investing in these specs and trying to come up with efficient data structures that all of these SDKs can use. Everyone's trying to solve the same problem to make sure that they are designed in a way that will scale really nicely.
One more question. Not sure if this is a duplicate. How do you handle tag explosion, attribute explosion?
Yeah, I think the attribute explosion problem is really dependent on which service. So while I say there's no vendor lock-in, every service has different pricing models. And so if you are using one like Honeycomb that has a wide event store, it doesn't matter. You don't get charged if you have 10 attributes on your span or 100. It's exactly the same pricing model. And I think that's where there's too much to kind of talk about in this space, but that's the idea of Observability 2.0, is trying to add all of that important metadata as tags on each of those spans, so you have solved that question of what should I log. You should just always attach all possible relevant metadata, and then you're being charged on the number of events that are being you're sending to those services, and that it's kind of a fairer model and doesn't tend to cause you these massive explosions of cost because you've included an extra attribute that's a bit large. So it really depends on the service, and as you start moving towards this observability 2.0 and services adopt that, you'll start seeing that like the pricing models change away from ingestion size, which is limit how much, like how many tags I'm sending, to more number of events, and just making sure that you structure that and your events give a good picture of what your application's doing and not super granular. So yeah.
Hugh Shot.